And with that, Mark and Natalie, why don't you guys go ahead and introduce yourselves before we get started?
All right, I'm Mark Clark. I'm an extension specialist in the area of wetlands and water quality within the Soil and Water Sciences Department on main campus in Gainesville, but have been working in the Cedar Key area on living shoreline since about 2011 or so.
And yeah, hey everyone, my name is Natalie Stevens. I graduated from the University of Florida in December with my bachelor's degree in marine sciences. And since January, I have been working under Savanna and Mark with the Living Shoreline projects in Cedar Key.
All right, awesome. So without further ado, we will go ahead and get started, and feel free to just pop any questions into the chat during the presentation. And then after we finish our slides, we'll open it up for questions. And Cassandra is going to be helping us moderate the Q&A session. All right, so hopefully you guys can all see my screen. And I just want to, because this is just a quick presentation, we're only going to be talking a little bit about how we involve volunteers in living shorelines and a little bit about an exciting new living shoreline material that is free of plastic, and Mark's going to tell you about that. And then we're also going to give a little status update on some living shorelines that we have constructed in the greater Daughtry Bayou area. But I just wanted to throw this slide up there to let everybody know that our Living Shorelines program at the Nature Coast Biological Station is actually really comprehensive, and we have a lot of different things going on, including classes for contractors and the public, and a couple of other partnerships and policy planning tools and things like that. But we just don't have time to cover everything. So we're going to cover a little bit about what we've been doing recently this year. And this is a nice map that Mark put together just to give you a little bit of the lay of the land in terms of where these projects are, the living shorelines that we've built here in Cedar Key. So the biological station is right here, for those of you who aren't familiar. And so these are really in our backyard. And so they're in the area that we call the greater Daughtry Bayou area of Cedar Key. And so first, I want to show you a little bit about what we've done over at the Airport Road site. And this project so far we've built the Oyster Reef elements of that, and we used these materials, which are reef balls that are constructed down in Sarasota. The particular size of these that we used are called pallet balls, and they are 1,300 pounds each, and they were trucked in on 11 semi-trucks to a place in Cedar Key where we staged them with the help of a generous community member, Royce Nelson. And then they were loaded onto a barge and deployed into the water. And this is just gives you an idea of what they looked like, a couple of different views of them at low tide or mid tide. And at high tide, they're actually submerged. So this was 16 reefs that were constructed. And I didn't put any pictures in here, but there's already lots of oyster growth on these, which is really encouraging. And we, of course, will be tracking that in addition to the response of the fish community and several other variables. But there's more to come on Airport Road, and we'll be bringing in some sand and really augmenting the vegetation along this area as well. And then another project that we just recently completed and we are in the post-construction monitoring phase of is the G Street Living Shoreline. And I'm not going to talk too much about these structures because Mark is going to cover that, but just suffice to say we built some Oyster Reef enhancements out of different structures than what we used over on Airport Road. The ones in the left here are called Oyster Castle blocks, and these on the right are Reef Prisms. And then after we placed those elements, we trucked in a lot of sand. And then again, Royce helped us with grading that sand. And after it was placed and graded, we were able to involve a lot of volunteers in the community to bring in plants across most of that shoreline. There's a small beach enhancement as well, as you can see in the upper left photograph there. And right now we're pretty much just in the phase of watching and replacing plants that get knocked out or washed away by storms. We did get a little bit of the edge of Hurricane Sally, and so we did have to do some replanting, but by and large, the project's doing quite well, and it's in a very public location in Cedar Key, so I encourage any of you to stop by G Street and have a look at this brand new living shoreline, as well as keep an eye on Airport Road. And with that, I would like to go ahead and hand it over to Mark so he can talk to you about this exciting new material we are calling Reef Prisms.
All right, thank you, Savannah. So as one element of living shorelines, oftentimes there's a waterward feature that is some sort of a physical wave break, but oftentimes also an artificial substrate designed to provide a substrate for oysters to colonize on. And so we have a physical wave energy reducer that might protect sands that were added, but also a substrate that we're catalyzing a natural oyster reef to develop. Ultimately, as those oysters grow and senesce, they will provide new substrate, but also are creating a physical rock. Basically, they're adding elevation to the site, which is one of the critical protective mechanisms. And so as you've seen, we've got some commercially available products. The reef balls you saw, which weigh in at 1,300 pounds, very physically present, very important if you've got high wave energy or high energy. You also saw what are called oyster castle blocks, which look like cinder blocks with a kind of interlocking feature. But oftentimes we're using loose shell that's put into a plastic mesh sort of bag, and we are trying to move away from any sort of plastics in the environment. We know that microplastics are a very significant problem, ingestion up the food chain and whatnot. And so we started to investigate these alternative materials that are all biodegradable. The internal mesh you see here, what looks like a fabric material, very loose weave. The actual fabric internally here is a jute fiber that has been woven into what typically would be used as an erosion control mat. And then that material is embedded in a concrete. It's not actually a Portland-based concrete. It's something called calcium sulfoaluminate, which is much stronger in its compressive as well as elasticity, but it also sets up quickly at a higher temperature. Literally at 80 degrees or more, it'll set within 15 to 20 minutes. So that fabric with concrete is then laid over a form and it sets up very quickly. And so you can see we actually deployed 90 of these individual structures that were then nested into a linear nested feature here, two upright triangles with then an inverted triangle, and that forms the sill. But these could also be just independent, didn't necessarily have to have a sill behind it. So there's another photo. You see now the intact sill. So all those loose pieces got formed, and then you saw the sand going in behind them. But right now we utilized an equilateral triangle. There's other shapes, pretty much any shape could be formed out of this material. And that's kind of the next step in our iterative process of developing this, is what exactly is the best shape. We've done some studies that clearly show oysters will settle, in fact, even prefer this substrate over other substrates. So that's not the question. It's really what shape might be best for survival as well as physical protection along the shoreline. Next photo or next slide. So might be there. All right, so that's just a brief introduction. You'll probably see or hear more about that material in the future. We've got other deployments going on around the state, and it's really trying to promote plastic-free options that are also not necessarily going to have to be in high energy environments, but as we move along the gradient from high energy to low energy and trying to implement living shorelines, this will provide one alternative. That is something the volunteers have helped us with. They see the middle lower photo. That was one of the volunteer events. And so I think Natalie's going to share with us a lot of those volunteer activities, but it's certainly something amenable to volunteer construction as well. So Natalie.
Yeah, thanks, Mark. So like Mark said, there's a lot of different activities that we do with volunteers, both university students and also local Cedar Key residents, and also visitors just coming to Cedar Key. So one of the things we'll do is marsh transplants, where we'll take some of the Spartina alterniflora or Spartina patens that is already on the shoreline, and where we're going to be placing sand fill, we'll take out the vegetation there and place it into somewhere like G Street, where we just put in the new sand. So a lot of the G Street plants came both from the shoreline of Airport Road and also from donor nursery marshes. We also do oyster relays, which is where we go out on the shoreline and clear the space where our 16 reef ball reefs are. So we go and clear all the healthy oysters out of there, so that way they're not smothered when, you know, the reef balls were put in or when the sand fill was placed on G Street. And we also, like Mark said, did oyster sill construction with a lot of volunteers with all the different materials, and we would do double wraps sometimes to make them stronger. Next slide, Savannah. And with that, and with volunteer help, on G Street, we got a total of about 5,030 plants. And those were from different plant species. We had some Disticulus baccata, we had some Spartina patens, we had dune sunflower, sea oats, panic grass, and Spaltrina alterniflora. In addition, with volunteer help, we got 2 castle block reefs deployed, which is what Savannah showed, those long strips of castle reef blocks. And we also created about 40 reef prisms for that oyster sill on G Street with volunteers. Next slide. And then on Airport Road, of course, we're still in the pre-construction phase, but we have gotten about 1,895 Spartina alterniflora plugs on the Zone B part of Airport Road. But once October to November starts, we're going to be doing much more planting on Airport Road as the sand comes in. So definitely, if you are interested in getting involved with those planting opportunities, follow the UF IFAS Nature Coast Biological Station on Facebook for updates. And yeah, these are just a few pictures of the amazing volunteers that we have had out on our shorelines. Since January, we've had about 467 volunteer hours in total with everyone, and that's over about 100 volunteers. So even during, you know, the pandemic and everything, we've had everyone, you know, willing to come out and, you know, really get involved with our different activities, which we really appreciate. And there will definitely be more volunteer days. So if you want to get some planting done on our shorelines, we will definitely need all the help we can get.
Great, excellent. Well, so I hope that gives you an overview of everything we've been up to in terms of Living Shorelines construction. It's been a very active spring and summer, and those photos that Natalie showed were from before the pandemic struck. And then since then, we've actually been wearing masks and being able to stay socially distant and stay outside. So it's really been nice that we've been able to keep our momentum and our progress there. So at this stage, we'd like to go ahead and open it up for questions. And if you'd like to direct your question to a particular panelist, please feel free to do that. And right now, we just have one question in the chat box. And maybe Mark, you could take this question. It's from Corinne, and she asks, are the oyster reefs made from concrete or are any other materials used? So we touched on it a little bit, but maybe you can go into a little bit more depth.
Yeah, the 2 materials that, well, 2 of the 3 materials that have been deployed as the oyster reef, the reef balls are a concrete that has a slight amendment in it to help buffer the pH a little bit, because generally concrete's very alkaline, and it's basically buffered so it's a little lower pH during its deployment. And then the oyster castle block is also concrete based. Now, the term concrete, of course, has lots of different formulations, and both of those 2 products are Portland based, or what they oftentimes call ordinary Portland cement. And so there's lots of different amendments, but it's based on a calcium carbonate reaction. Whereas the reef prisms that I talked about, they have a different formulation of concrete, which is based on this calcium sulfoaluminate. And so it's got a aluminum component to it, but it also results in a much lower, or 50% reduction in the carbon, the CO2 footprint of the cement curing process and construction process. Plus, as I mentioned, it sets up more quickly, it's stronger, and so the actual size of the structure can be decreased, and that's one of the reasons it has a smaller carbon footprint. So they're all made of quote unquote concrete, some of which are made of Portland cement based concrete, others of calcium sulfoaluminate.
Awesome. Thank you. Yes, we've learned a lot more about concrete and cement formulations than I think any of us ever thought we would know. Okay, so the next question is, are there economic estimates that try to put dollar values on the ecosystem services for the Cedar Key living shorelines? And I can just briefly answer that, that yes, we are working with Ashley Smith, and she has amended her economic ecosystem services valuation model that she created in North Carolina, along with several co-authors. It's published in Bioscience, but she's adapted that for use in Florida. And so we are able to apply that calculator on an aerial basis for the habitats that we've created to try to get some ecosystem service estimates. And there is a forthcoming EDIS publication, which is basically an open source version of the model that anybody, any managers or other folks that might be interested in those numbers could apply. So yes, that is out there, Holden, and very helpful for communicating the value of these systems. Okay, so the next question, while creating the living shorelines addresses erosion, how do you also address climate change and the rising sea and its part in the erosion that Florida coasts are facing? And I'll kick that one to you, Mark, since I know you've thought a lot about water levels and how they're going to change in the future already.
Yeah, and so in short, basically these living shorelines really don't address, like say, storm surge water level changes. They're really about wave energy reduction, absorption of that wave energy. But the indirect connection with climate change and how it may assist in climate change is you've got a system that is assimilating CO2 in the form of calcium carbonate. If you're creating oyster shell substrate, you've got carbon it's accreting in the soil. We call it blue carbon oftentimes. So if we're accumulating organic matter in our sediments, we're locking up a certain amount of CO2. We're allowing for vegetative growth. It's turnover, but basically it's still biomass that's being captured. So there are some carbon sinks associated with a living shoreline as compared to, let's say, a hardened shoreline that might be composed of concrete. We know concrete, meaning Portland-based concrete, actually generates about 8% of our total CO2 emissions on the planet. And so activities that prevent hardening from the use of concrete, Portland-based concrete, would be one indirect benefit. Even though that may not take CO2 out of the atmosphere, it prevents more going in. So in short, really, we don't have a mechanism to mitigate for the sea level rise directly with the living shorelines. We have indirect mechanisms. But basically that's the long-term fate of these shorelines is still going to be challenged with the rising sea levels. This is really about a wave energy buffering along these shorelines that can be done, including the environmental services, and not just through a hardening of that shoreline.
Yeah, and I'll also add to that that the naturally occurring marshes and oyster reefs have been shown in certain contexts to be able to keep pace with sea level rise if they can capture enough sediment to accrete or build land vertically or horizontally. But that's also predicated on their ability to move landward as well. And so a lot of these living shorelines are built right up against some sort of situation that would prevent those habitats from migrating landward. But it is potentially the case that these shorelines could help buy some time for the property behind them if they're able to accrete and build land, and rather than having the erosion just directly remove it. So we keep that in mind too, although it requires that you have adequate sediment supply and other things like that. So it's not always the case, but it can be the case. Okay, so we have another question about if we ever have problems with transplants or if we have any plans to add new plant species.
I think Natalie can answer that one. What did we do? What did we do on Monday?
So we do actually have, some problems with transplants. With the latest storm, we had a lot of the vegetation washed out. That could just be due to it not having enough time to establish its roots. It could also be due to not having a deep enough hole in the ground for it to grow. Can also be, sometimes when you take a plant, from a donor marsh or something like that, it's not used to the conditions that it has now in its current shoreline, so it can't do well there. So it's definitely very variable when we can have, problems with our marsh transplants. But, all we can do is go and replant and hope for the best. But yeah.
Sure, yeah. So if a storm whacks it right when you put them in, there's not a whole lot that can really be done for that. And so we did get a little bit unlucky, but I will say that over at Airport Road in our Zone B plantings we did this spring, we had almost no loss of those, and we didn't have to replant over there at all, except for a little bit of the patents got a little bit too dried out because we had a bit of a dry spring. So other than that, it really is kind of a little bit of luck involved in the conditions that these plants face in that early phase. But kind of in contrast to shoreline armoring and seawalls and things like that, the strongest a seawall will ever be is the day that it's installed, or at least after the concrete is finished curing. So basically right at the beginning is the strongest that will ever be. Whereas these living shorelines, they build strength and resilience and they get stronger over time. So certainly there is a little bit of maintenance on the front end, but we were pretty happy with how it performed with that wave event we got from Sally. Okay, so another question, how do these living shorelines affect the biodiversity of the area? And I don't know if, Mark, you want to talk a little bit about the fish community patterns we've been seeing over at Joe Raines, and then maybe Natalie, if you want to talk a little bit about the fish monitoring we've been doing at the other sites to answer that question.
Yeah, sure. So the two sites we talked about mostly today are ones that are in their implementation phase, whereas another one that you might have picked up from the original map we showed is one called Joe Raines or Joe Raines Beach. And that was a living shoreline that we installed back in January through March of 2017. So we have had multiple years now of an opportunity to monitor that site. And we track various different things vegetatively and whatnot. And one of the interesting aspects is we've been using minnow traps to track fish composition and biomass within a native marsh site, the beach area, which was had sands added but no vegetation added, and then in the area where sands were added but also vegetation was added, so a true living shoreline marsh area. And after the first year, we basically had the native marsh being completely independent in the sense of its composition and biomass relative to the beach and the newly planted vegetated section of the living shoreline. And so essentially there were two discrete populations, with the newly planted living shoreline being more similar to the sandy beach than basically the native marsh. But over the years now, this is our fourth sampling this past summer, the community composition of fish within the planted marsh zone has become increasingly and now non-significantly different than the natural marsh or the native marsh, and now is significantly different than the beach. And so we have seen a convergence towards the marsh community with the constructed marsh section, the living shoreline. And so as a result of what was there previously, which was essentially not a beach, but more of a mud flat scenario, the diversity has changed, but then it's also converged to be more like the native marsh site than the beach site. So we've definitely seen a mimicking of a natural composition of those fish species towards the native community, which is the one we're trying to emulate, because those are doing very well as a natural shoreline buffer.
Yeah, and to go along with that, for the pre, during, and post-construction phases of both our living shorelines on G Street and Airport Road, we've been doing fish monitoring, which consists of going out and putting pike nets and minnow traps for 2 days every other month. And what we will do is we'll put the either pike nets or minnow traps on the natural reference, the hardened reference, or the living shoreline sites on our shorelines. And that is going to be used, in the future to see how much of an impact the living shorelines do have on the biodiversity of the area. So we'll see, if the vegetation and, the sand really are helping promote more fish diversity, more crab diversity, and all different types of other different animals that will visit our shorelines. So that's really fun to do. And we do that a lot every other month.
Next Monday. Tuesday.
Yep, next Monday and Tuesday.
Right. Yeah, and it's really interesting to see too that it seems that that Joe Raines site is also part of our sampling, and we always get a really high diversity of fish over there. And so we hope that our new living shorelines will converge with that. And I think that matches well with studies that have been done in other areas, that they slowly see a convergence toward the natural marsh community, and it takes about 3 to 5 years to see the Nectin communities be similar, at least in other states. So it remains to be seen if that pattern will still hold here.
We've also
All right.
just to add just a little bit, and the biodiversity is something that you have to take into context of the broader area. But the other thing we've seen is utilization of the Joe Raines Beach shoreline, and I wouldn't be surprised that we don't see it maybe even here at G Street, but utilization by species like diamondback terrapins, and actually nesting along the shoreline after the living shoreline intervention, whereas previously there was no evidence of that. And so I think we actually open it up to utilization by species we know are in the area, but we're creating habitat that would, in a sense, broaden that overall biodiversity. Now, we may be displacing other species to other areas as well, because we're shifting from, say, a mud flat or a intertidal sandy beach to perhaps a higher, drier beach. But again, we're diversifying that structure at the larger scale by doing these living shoreline interventions.
Awesome. Yeah. Okay, well, we have 2 more questions and we will get to them, but since it's nearing the end of our pre-planned time, I want to go ahead and just launch a quick exit poll before we have, oh, sorry, 1 second here. I don't know, for some reason it's not letting me, there we go. All right, so you should see a poll pop up on your screen, but we'll continue with the Q&A as that is going in the background. So probably the quickest, I'll get to Holden's question in a second, but Mike asks, could the same plants be used in the panhandle? And I would say generally yes. The plants that we used in this restoration are herbaceous marsh plants and some dune species, and most of them have distributions that go much farther north than Florida in general. And so the panhandle would be a great destination for a lot of the same plant species. And then, so Holden's question is, has this type of multi-level restoration been done, or is this the model, or some of both? And so I'm not exactly sure what you mean by multi-level restoration. Is that meaning that we did, oysters all the way up to high marsh and dune, or could you clarify that a little, Holden?
Intertidal, and then all the way up to like the Spartina or mostly dry level.
Okay. Yeah, I mean, I generally see most living shoreline projects focus more on the low marsh and the oysters. I think it takes a lot more heavy lifting in terms of permitting to be able to bring in the amount of sand that it requires to build up to elevations that you need for high marsh and dune. I don't know, Mark, if you have thoughts on that, but I have not seen many living shoreline projects that restore the spectrum of habitats as these, or at least routinely do so on a larger scale.
Yeah, I mean, I think it ends up being site specific in the scale that you can either financially operate at, or you have availability to work. You pretty much, there's a natural, what we refer to as repose of the shoreline based on the composition of the soils. And so if you want to bridge a much higher gradient of elevation, that repose is going to force you to be much more horizontally distributed as well. And so, depending on how much room you have to work in, I mean, I think that depends on, again, your goals. I mean, these have been somewhat ambitious projects in the sense of trying to move across those gradients, and we're excited to see how successful we're going to be.
Great. Awesome. Well, I don't see any more questions and we are after 5. So I think we'll go ahead and say thank you to everybody so much for joining us. And we do have one more week in the Nature Coast Currents series. Next Thursday from 4 to 5, there will be presentations on the Lone Cabbage Reef and then also a tour of the station and some of the improvements to the wet lab and the aquarium room that have been done. So check out our Facebook if you would like to go ahead and register for those events. And thank you everybody for your time this afternoon. And also thank you to my panelists, co-panelists, Mark and Natalie, for joining me today to tell you guys about this work.
Thank you,
guys.
everybody. And please join us for a volunteer event if you can.
Yep. October, November. We'll see you there.